All right. Oh, that looks terrible. What have I done to myself? I'm leaving this in this video so you can see some of the behind the scenes. Isn't it fun and exciting? I forgot. I knew that was going to happen, but I started the video anyway. Like I was trying to say before I was so rudely interrupted by myself, I guess. We're going to talk about two-dimensional figures. This particular video is probably a little bit more dense than the rest of the ones we've seen so far in this chapter. This one, along with the other one, it's got more stuff in it, but it's gonna be okay, is what I'm trying to say, because it probably is pretty much completely review as well. So we're talking about two-dimensional figures, right? So we're going to talk about shapes. So we're going to talk about, first of all, what is a polygon? A polygon. So a polygon has a few different criteria. First of all, it is a closed figure. Closed figure, right? So, for example, this would be a closed figure. See, it is completely closed. So this is a accurate example of a closed figure. A non-example would be something like this. See, it doesn't actually close. So that is a non-example. That is not a closed figure. So a polygon is a closed figure with a finite number of sides. Finite, so not infinite, number of sides. So what is a polygon with an infinite number of sides? Other than not a polygon, that actually, got it? That actually turns, generally speaking, into a circle. If you keep on adding more and more and more sides to a polygon, at least a convex one, which will show the difference between that we'll show what that word means here in a second. But a convex polygon, if you keep on adding more and more sides, more sides, it turns into a circle or an oval or some shape like that. So, as I just now alluded to, our next vocabulary words here are going to be, excuse me, convex and concave. You probably have already heard these words. The easiest way to remember the difference between convex and concave is if you take a look at this word right here. Concave has a cave in it. Let me show you an example. So an example of a convex polygon would be something like this guy right here. That's a convex polygon. So is this. A concave polygon would be something like this. See how it's got a cave in it, right? Something along those lines. So let's see if we can draw another type of concave polygon. These are polygons because they're closed and they have a finite number of sides, but they are concave polygons. We could draw infinite number of examples of these types of things. So another type of another vocabulary word related to polygons is regular. Regular. So what is a regular polygon? It is a polygon with all equal side measures. And if you have learned this in a previous class, they probably didn't add that word measure on there, measures. But I want to make sure and highlight that because we're making a big deal in geometry about the difference between the measure of something versus the look of something, right? And so all equal side measures. So I don't know that I can draw this perfectly, but no, I've already messed up. Also has equal. You know what would be smarter? brilliant. Sometimes I get in a flow and I forget what I'm doing. Where is the button? Something like this. How about that? This guy right there would be a regular polygon. That's in fact a regular octagon. Let me make it bigger. Right? So it has all the sides equal measure, so we could label that with, oops, had another, I didn't mean to make that pink, but that works. It's fine, no big deal. All the sides are equal. So this and this and that and the other one and this one and that one and this other thing and that one, all of those sides are equal. Also, all angles are equal. So if it is equilateral and equiangular, all angles are equal, then it is a regular polygon. This one's a regular octagon. You could have a regular pentagon, a regular heptagon. We're actually going to go through all those different words next, I believe. Yes. Okay, so different shapes with different sizes, as you probably know, have different names, right? So, and you probably know a good chunk of these. You may not know all of them. So let's kind of make us a little chart here with number of sides. And over here, we're going to put the name. Okay, so we can't make a two-sided figure. That wouldn't exist. That might be a line, I guess, maybe. I don't know. The smallest number of sides, of course, we can have is 3. You almost certainly know what a three-sided figure is, and that is a triangle, right? Angle. Easy peasy. Now, a four-sided figure may be a little bit tricky because 4, you may know that the prefix for 4 is quad, right? All right, so, excuse me, the prefix for 4 is, I don't even know. It's escaping me. Prefix for 4 is not quad. It's something else. I don't know. It may not be confusing. Let me know in the comments. What's the prefix for quad? I didn't prepare that in my head, obviously, very well, but there we go. But I did tell you that, but I did hint at you that a four-sided figure is called a quadrilateral, right? Quadrilateral. Okay. A 5-sided figure is called a pentagon, right? That one, these so far, you probably know these. You may or may not know quadrilateral, but Pentagon. What is a 6-sided figure? Hexagon, right? Hexagon. So these you probably already know for whatever reason, and I've never quite understood this. You know, when I started teaching this in math or science or whatever, any other place where we talk about prefixes, for some reason, a whole lot of people don't know what a 7-sided figure is called. I've never quite understood that, but a 7-sided figure is called a heptagon with a P. Heptagon. And then we know what an octagon is called oftentimes because of stop signs. And I already said that one earlier with that earlier example. An 8-sided figure is called an octagon. The Octomom has 8 kids, at least I assume. I never watched that show. Did you watch that show? Let me know down in the comments how great that show is or whatever else. You know, I say that kind of stuff all the time in these videos, and nobody ever does it. It makes me feel sad inside. No, not really. Okay, so 9 is another one that a lot of people don't know. A 9 is a nonagon, which kind of 9 and nona sound kind of similar. So that one, I don't know why we don't know that one, but there it is. Nonagon. A 10-sided figure is a decagon. I think pretty much all, if not all of these prefixes come from Latin, in case you're curious. You may already know that, but there you go. 11 is definitely one that a lot of people don't know. It is a hen decagon, like a bok, bok, bok hen, right? Hen decagon. Decagon. And a 12-sided figure. We're almost through with this chart in case you're getting stressed out at this point. Don't worry, we're almost through with it. A 12-sided figure is a dodecagon. Gone. And a 13 plus, so 13, 15, 145 teen. Oh, wait, kind of broke it, but you get the point. All right, anything beyond 12 we call an N gone. So, in other words, if we have a 50-sided figure, that would be a 50 gone, right? Or 100 gone, or a 15 gone, et cetera, et cetera, et cetera. So that's I guess mathematicians decided, okay, that's fine. We don't need to label anymore. We're just going to use the numbers we already know. But these other ones we see often enough, so they gave special names based on Latin, because of course they did. Everything in math and science seems to be based on Latin. So there are two things that we often do with two-dimensional figures. One is we calculate their perimeter. That's how I remember how to spell it. How do you remember how to spell it? Let me know in the comments. I'm going to keep on saying that until people start telling me things. You're like, that's fine. We're not worried about it. We're not going to put anything. You can just keep saying whatever you want to say. No big deal. So we can find the perimeter of it and the area of it. So what is perimeter? This is almost certainly review at this point. Perimeter, we add up the sides, right? Add sides. The units are units to the first power. Area, we have to use a formula of some kind, and it changes. But we're pretty much always multiplying something. So let's look at, if we're not going to do formulas for how to find the area of all of these figures. There are, and we'll actually see some of these later, quite a bit later. There are formulas that we can find the area. We can find the area for any regular polygon. And some of those things. So, but we're going to kind of focus kind of up here at the top. And then we're also going to put one other that I've already mentioned, but we didn't write on here, that is not a polygon, but is but we have formulas for. So for perimeter of a triangle, we're going to look at a triangle first. Draw us a triangle right here. Perimeter of a triangle. How do we find it? So if we have sides C, D, and B, to find the perimeter of it, P for perimeter, right? We add up C plus B plus D, right? Easy peasy. We add up the sides. Now we need one more piece of the puzzle, right, to find the area. If you know this formula already, then you already knew this, because we need an H for height, right? Because to find the area of a triangle, we take 1/2 of the base B times the height, which is the same, in case you are curious, as multiplying the base times the height and dividing by 2. That's just a little simple algebraic rearrangement, right? So if we have a square shape, which is, we're gonna call this a square, because why not? So all of these are equal. All of these are 90. Look, it is a square because I said so. Which is, say, I was making a big deal in the last couple of videos or so about it's not true unless you say it, but on the flip side of that is you can draw it kind of sort of bad and then label it, and it is that thing. Yay. Right? Okay, so we've got a square, and we're going to label all the sides. I'm actually going to, I kind of messed this up, but I'm going to change colors here, right? So we keep it kind of organized. All the sides are the same length. So in this case, we'll say side, 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 S, S, S. So to find the perimeter of the square, now this is kind of fun because it has 4 of the same thing. So we would multiply 4 times S for a square, right? Area of a square. Now, an area of a rectangle, which we're going to write below here in just a second, we do length times width, right? You probably know that. So on this case, it's side times side. We know that if we have like bases, you add the exponent. It's 1 plus 1. I'm doing that over here. You can't even see that. 1 plus 1 is 2, right? So area of a square is side squared. Easy peasy, right? So to do the perimeter and area of a rectangle, we're gonna write formulas for rectangle, and then we're gonna write formulas for a circle, in case you haven't already guessed that, as the last one. And then I think we have an example, but I don't know if we're gonna do. Oh yeah, we do need to do that example. Just kidding. LOL JK. We do have an example that we need to do in this video. I told you this is going to be a little bit longer one, a little bit denser, but it's pretty much review. So hopefully easy peasy, right? So for the perimeter of a rectangle, these are equal. I mean, all 90. These are the same, and these are the same, right? There are 2 L's here, so 2L, plus there are 2 widths, so 2W, right? Easy peasy. And I already let the cat out of the bag to find the area of a rectangle. In case you didn't already know, by some minor miracle, you multiply the length times the width. Now, our last shape is a circle. Oh, that's not a circle. That's an ugly egg. I think for the circle, we are going to use a tool. That looks great. Perfect. There we go. Circle. Now, what we need to do is we need to label something on this circle. Let's put it there and go back to here. There we go. So for this circle, from the center point, sorry, got something tickling my throat all of a sudden. From the center point out to the edge is called, we're going to label R for radius, right? If we do 2 of them, all of it together, that's the diameter, of course, right? So, in fact, we can even label that. We can go from here to here. Whoops, wrong button. There, and then back to here. We can label that as the diameter. Probably should have changed colors. Sorry, but I think you got this. This should be review, hopefully. So, to find the perimeter of a circle, we give it another name, for one thing, right? We call it the circumference. Circumference. And to find it, we use this formula right here. We do 2 times pi times the radius. Okay. Now, to find the area, there's no fancy name for the area of a circle. It's just the area. To find the area, we use the formula pi times the radius squared. There we go. Easy peasy lemon squeezy. We are going to do one example. It's not going to be a hard example, but it is a little bit on the long side. So strap in, and we got this. So we are going to, example 1 and only, find the perimeter and area of quadrilateral, and we usually use a little kind of parallelogram looking shape to represent quadrilateral. Quadrilateral A, B, C, D with vertices A, -1, -1, B, 2, 2, 2, 2, C, 5, -1, and D, 2, negative 4. Now, you notice we're doing this on the coordinate grid. I didn't even bring one in here because we don't really need it. Although I am going to make a little sketch so we can see what's happening and we can kind of think through what's going on, right? So this is going to be our sketch for this problem. We're going to draw. Let me actually move that over, give myself a little more space than that. We're going to draw our axes. And we're going to label them X and Y. And then we're going to go ahead and plot these points. I'm not super stressed about getting it perfect, but it's going to be helpful to kind of have a picture. So negative 1 is right here. So there's one vertex. And then 2 is about right there. There's another vertex. And then 1, 2, 3, 4, 5. Negative 1 would be a vertex about right there. And then 2, negative 1, 2, 3, 4 would be about right there. Right? So now let me connect my dots and turn this into a quadrilateral. Looks to me like looks to me like I've drawn it off scale because it should have been a rectangle, but mine turned into a parallelogram. Why did mine turn into a parallelogram? Did I copy it down right? 2, negative 4, 5, 5. Oh. You weren't here to yell at me. You're probably screaming at me through the thing. I see what I did. Y'all already figured it out, didn't you? You totally already figured it out. Did you copy it down like I did it? Because if you did, you got to pay attention because sometimes I do things wrong on purpose. This wasn't one of those times, but sometimes I do. So negative 1 is in fact right there. That's great. 2 is right there. But this should have been 1, 2, 3, 4, 5, negative 1. Which should have lived right there. I don't know what in the world I was doing. 2, negative 4 was correct. So that 1 point was wrong. So this turns out to be a square. It's beautiful. So which is great, because we only need to find one of these sides. Now, so how do we find the length between 2 points? Well, luckily for you and me and us, we just reminded ourselves or learned brand new about the distance formula. So we just need to find the distance between a couple of points. So the distance formula is D equals the square root of x1 x1 minus x2 squared plus y2 minus y1 quantity squared. I mixed those up, but it doesn't matter. It does matter. How have we been writing it in here? We've been putting the 2 first, right? Like the other thing. Sorry, y'all. I threw myself off and now I'm writing everything in the world wrong. How about 2 and 1? X2 minus x1. It doesn't quite matter, but they do have to match, right? So, well, actually in this particular formula, since it's squared, it actually didn't matter. But now that I've confused you, I was really trying hard not to confuse you. That's okay. No big deal, right? Y'all still love me anyway. We're going to plug in our things. So let's use this as x1, y1. We're just picking 2 of them in this particular problem. And this I said 1, but then I wrote 2. This one as x2, y2. So we're going to put x2 right here. So we're going to turn that into a 2. And then we're going to subtract x1. So subtract negative 1 squared. And then bring down plus. And then y2 is going to be 2 minus x2, which is also negative 1. We're going to square that. So then we're going to walk on down and get the solution here. So we've still got the square root of 3 squared. Don't forget to ka-chink, ka-chink, right? That'll, if you got that wrong and you're like, wait a minute, that's probably what happened, because minus a negative turns into a plus. See, I don't get everything wrong. Plus 3 squared again. So that equals the square root of 9 plus 9, which equals the square root of 18. So we have a square here, right? So since we have a square, excuse me, since we have a square, our formula for its perimeter is 4 times s. So its perimeter is the square, 4 times the square root of 18, right? I should probably write that down on the screen. Perimeter equals 4s. Each one of these sides is s, right? The formula for the area the formula for the area of a square is side squared. So in this case, that would be area equals the square root of 18 squared. What happens to square and square root? They cancel. So the area of this figure is 18 units squared. We probably should say square units. Square units here. And we should probably say units here, right? And that's all for this one. We have one more in this particular unit, which is going to be talking about 3-dimensional figures. So we're going to be talking about surface area and volume and all of those things. We will see you there. Thanks for joining us. I'll see you in class, all the things. Have a grand and glorious day. Don't forget to like, comment, subscribe. See you later.